This video is looking at the logs.g section of the logarithms module. In this video we're looking at identities and properties of logs. Now logarithmic functions can be applied to problem solving, can simplify logarithmic expressions to solve equations. The following three identities that we will look at can assist in simplifying expressions, and they have been developed because of the relationship between exponents and logarithms. So the first identity we have here is that log a, or log to the base a of a, equals 1. The key here is that these are the same. Whenever that's the case, your answer will be 1. Our second identity is log to the base a of a to the n equals n. Now you can see that this part here matches what we had in identity 1, so that's equal to 1. And you'll also see with our log laws that that n can come out the front, and that's why we get n. Our last log law is log base a of 1 equals 0. So whenever you have a 1 here, your answer will be 0, no matter what the base is. Okay, and you can see from down here that I've shown you where these rules are coming from. They're coming directly from our exponential laws. Okay, so let's try and simplify some logarithms by using our identities. The first one here, log base 8 of 8. Again, these are matching, so the answer is 1. Log of 10, remembering log of 10 is log to the base 10 of 10. Again, these are matching, so our answer is 1. In the next one, this is like parts A and B, where we have 3 and 3 here. As I said to you, one of our log laws, that 4 can come out the front, so our answer is basically 4 times 1, which is 4. Next one, log of 100, log to the base 10 of 100. That can be written as log of the base 10 of 10 squared. Now, this here is equal to 1. That 2 can go out the front, so our answer is 2. Next one, log of the base 2 of 1. We have our 1 here, so our answer is 0. Next, 10 to the power of log x. Okay, in this one, it's like these cancel each other out because they're inverses. 10 to the power of and our log of the base 10, so it leaves our answer as simply x. Okay, and that follows on, go back one step from here. See how this base and this base match? It's like they cancelling each other out and leaving that n. Okay, so we've got x. Next one, natural log of e. So that's log to the base e of e. Again, these are matching, so our answer is 1. Next one, natural log of 1. We have a 1 here, so our answer is 0. Next, natural log of e to the 6. Okay, remembering that's log e of the e, or to the power of 6. This is equal to 1. Our 6 comes out the front, which you'll see soon, so our answer is 6, because it's 6 times 1. And our next one, e to the log e of x. As I said before, see how these bases here are matching. They cancel and just leave you with x. Okay? So now let's look at our log laws. The first one that we have is the product property. Now these are very similar to our exponential laws. Log base a of x, y is the same as log base a of x plus log base a of y. So when we're multiplying here, this is a multiply between here, we end up adding to split it up. Okay, so that's analogous to our exponential law, where when we're multiplying two exponentials with the same base, we add the exponents. The next one, log base a of x divided by y. So here we have what's called the quotient property. We're dividing. And what happens if it ends up with log base a of x minus log base a of y. So when we're dividing, we subtract. So that's analogous to our division law in exponentials, where when we're dividing, we subtract the exponents. Our next law, power property, log base a of x equals n. This is the one I was referring to when we looked at our identities. That n just comes out the front. Okay, so it's n log a of x. Okay, that follows from our power rule from our exponentials. Our next one, our change of base rule, we've already looked at this. Log base a of x, if we want to change the base to b, for example, it'll be log b of x over log b of a. Okay. So let's do some examples here. What we're trying to do is rewrite these in another way. So we're in the first one here, we're going to expand it out. Log of 10x. This here is being multiplied. It's 10 times x. So we can expand that out as being log of 10 plus log of x. Okay, so we're using the law that log base a of xy is log base a of x plus log base a of y. Okay, now you can go one step further here, and I shouldn't be working across the page, I should be working down the page, but I don't have enough room. But this is a base 10 here. These match, so that's actually equal to 1. So I can rewrite that as 1 plus log of x. Again, remember we should be working down our page with equal signs lining up. Our next one's a division. So when we're dividing, we subtract. Okay, so it ends up log of 4 minus log of 5. So that's using the law log a of x over y equals log a of x minus log a of y. Next one, log 4 of x to the power of 3. There's not much we can do here. We can move that 3 out the front and rewrite it as 3 log 4 of x. Okay, next log 2 of 100. This one you might look at, it might seem a little bit tricky of what we can do here. One way you could do it is just change the base. So we could write log of 100 over log of 2. Now how do I know to do that? Well, I know that this log here will become a base 10, and I also know that 100 can be expressed as 10 squared. So I'm writing it as a factor of 10. So that means my next step, again I shouldn't be working across, but I can write log 10 of 10 squared over log of 2. That 2 comes out the front. Okay, and then this is all equal to 1. So we've got 2 times 1 is 2 over log 2. Okay, practice, you'll get used to these. Log 3 of 6, there's not much I can do here besides just change the base. If I change the base, then that's something I can go to my calculator and plug in and get an answer. Okay, so at least I can do an extra step by going to my calculator there. Now when I'm looking at these, it says, first one says write as a single logarithm, and I'm again going to use my log laws here. How can I write this as a single logarithm? Well, firstly, that 3 can come up as a power, the same as that 2. So I'm going to do that first. Log b of x to the power of 3 plus log b of y squared minus log b of z. Okay, now I'm going to look at this bit here. And we have a plus, so that means I can rewrite that as log b of x cubed times y squared, and then I have minus log b of z. Now I have the minus here, I can go to a divide. So I've got log b x cubed y squared all over z. And I'll put brackets around that. Okay, now let's go the opposite way. Here I have 1 log. I want to expand it out. Okay, so I know that this here is being multiplied, so it's going to come and become a plus. Okay, then that's all being divided by z cubed, so I go minus. I can go one more step here and I can bring these powers down. So log b of x, this square root of y is the same as y to the power of a half, so I can bring that half out the front and write log b of y, and then I can bring that 3 out the front and minus 3 log of z. Okay, again, it's just practice. The more you do. Next one, use logarithmic properties and identities to simplify the following. So here I have 1 plus 3 log 2 of x. Now, I've got a single 1 here, and then I've got a log here. How in the world can I simplify this? Well, my base is 2 here. I know that log base 2 of 2 equals 1. So if I replace that 1 with log 2 of 2, and then I write plus, and I'm going to rewrite the next bit with the power of 3. So I've just moved that 3 to be the power. You can see how this is leading into a single log, because now I have a plus happening in the middle. So that means multiply. So I get log base 2 of 2x cubed. Again, you can put brackets around that if you want. Bit tricky, but again, practice. This one has, I've already got 2 logs and I have a plus in the middle, so I can write that as a 1 log. So I can go log of 25 times 4. So log of 100. Getting a bit overzealous there. Now remembering that this is a base 10, I can rewrite that as log 10 of 10 squared. So what you should be realizing, whenever we have a factor of, a multiple of 10 here, then we should write it as an exponential. So for example, if I had log of 1,000, I would rewrite that as log base 10 of 10 to the power of 3. Okay, so that should be your little hint. That 2 can now come out the front. Log base 10 of 10 is simply 1. So it's just like saying 2 times 1 is 2. So it's using your identity. What now? Well, probably lots of practice. I think the more you do these, the easier it becomes. And there's an exercise in the textbook, Logs G1, for you to do. Again, if you need to, listen to the video again. Make sure you understand it, because log laws are very important.